Hello viewers, welcome to this session. So I'm your teacher, Mr. Sirwimba. So we have this particular paper 2019, paper 1. So we'll try to go through together on this question paper. We see the question on Seco theorem. We see how it was given, and then the properties, because whenever we are looking at Seco theorem, what we have to focus much is on is properties. How is the property presented? Then what type of property is it? Identification of properties, what is most important. So we'll first of all start with identification. Not solving but identifying the property. So in identifying the property, the first property which we'll look at, we have the property which we call angles in the semicircle. I'm just giving an overview. Angles in a semicircle. So a semicircle, so we have a semicircle in that form. So angles in the semicircle, they add up to 90. Are we together? They add up to 90. So those are angles in the semicircle. So angles in the semicircle, they add up to 90. So how do we identify? This is a 90-degree angle. That's a 90-degree angle. So if you have angles inside like that, we can subtract them from 90. Let's say you are given, for example, like in our case, 30 there. What would be this angle? This angle, to find it, we say 90 minus 30, and then you will get the value from there, which is when we subtract here, we'll get somewhere 60. Somewhere there. I'm just giving an example. So that's one property of which we call angles in the semicircle. So angles in the semicircle adds up to 90, because many times and so many points I've seen pupils getting confused much with this property. So whenever it is presented, we can see it like this. Look at this. We look at the three letters being given. So whenever you are answering questions regarding Seco theorem, you look at the letters given. So you are given CBD. You are given CBD. So what we are having here, we have CBD. So these three letters, they should give you a property, and then the angle in the middle is the focus, which is the angle you are finding. So in our case, we have the three letters CBD. So C, and then going to B, and then going to D, like that. So this is the shape which we have. So if we recall this shape is a semicircle. So whenever a semicircle is presented, it's presented like this. This is a semicircle. So where this is a 90-degree angle, and then this one, we have these angles down there. So we have to take note that this is 90 degrees, because sometimes they might trick you. Like in 2023, the examiner there went on to ask a simple question, what is this angle? But they asked it in three letters. So this is always a 90-degree angle. Take note, that's a 90-degree angle. So now, to find, for example, B, which is this one, we can just say 90 minus minus 30. Then we will have, when we subtract these two, we should have 60. We should have 60 from there, 60 degrees. That's what we are having, out of an example. So we have this property, which we call angles in the semicircle. So let's try to move on, to the other property. Let's look at the other property that we are presented with. Because the examiner aligns properties, and then from there it's your duty as a pupil to identify the properties. So we have to know how to identify the properties. So in our case, we look at the second question. BAC. We have B. Let me try to show you. BAC. Now, before we answer this question, my target is not to answer the question, but for you as viewers and pupils to understand the property behind of the question. Look at this. We have this particular shape, and then the property that is being presented, we call this property, let me try to say a property. This property, which we will try to utilize, is said to be angles from the same segment, they are equal. Angles from the same segment are equal. So whenever you are having angles from the same segment, they are equal. So if this is an angle there, then you have an angle there. These angles, they are equal. Okay, so for example, I will just give an example. This is your C and then this is your B. These are points where angles are originating from. So these are origins. So let's say, for example, there is an angle that is starting from C, touching the circumference, returning back to B. Okay, this angle. Then also there is another particular angle starting from C, touching the circumference, and then returning back to B. These angles which are coming from this particular point, okay, they are equal. They are said to be angles from the same segment. The angles from the same segment, they are equal. Okay, it's the same as the angles from the same arc, they are equal. So here we have this one as a segment. Look at this one. This one is a segment. This one and that one, they are a segment. So which angles are coming from C, touching the circumference and then turning back to B? We try to use C. We have this one is starting from C, touching the circumference and then returning back where? To C, to B. Then also there is this one starting from C, touching the circumference and then turning back to B. So these angles, they are equal. They are said to be angles from the same segment. They are equal. So if we have 30 there, then this one also will be 30. Okay, so these angles, they are from the same segment. They are equal. Okay, so we can write from here the particular discussions. I hope you are clear on how I'm coming up with this. Okay, so here we are having 30. We are having 30 there as an angle. So therefore we can write from the parts, we can say 30 degrees. Okay, so we have 30. And then if we were to state with a reason, they are angles from the same segment. They are angles from the same segment, they are equal. Okay, so that's what we're having for that part. Okay, so we move on. We look at the other items. So the other question that is being given, we are also told that find A or B. Okay, we are told find A or B. A or B. Okay, A, O, and then B. This particular angle. Okay, this angle here, A or B. Now, if we see A or B, oh sorry, let me not say to this side. It's to this side, okay, not A or D, but A or B. Look at this. So we have angles which are said to be A or B. Now, to find this angle here, there are two properties which I will try to show you. Those properties, they will lead us to the final property that we use to find the answer. Okay, so I'll talk about two properties. So the first property which I'll talk about the property of alternate segment, angles in the alternate segment. So angles in the alternate segment, they are equal. So let's say this is a tangent. When they say an alternate segment, it has a tangent. The tangent is present. Okay, so there is a tangent. Okay, tangent is present, and then also we have the right angle triangle inside there. Okay, the right angle triangle is projected in this form. So this is a right angle triangle. So this particular shape, we call it an alternate segment. Now this angle here alternates to the angle which is inside there on top. Okay, this angle and that one, they alternate. Now take note where the angle is starting from. The angle starts from the tangent. Starts from the tangent and then it touches the right angle triangle inside. Okay, and then this angle is equal to that one. Then also this side the same. Here we have the angle starting from the tangent, then touching the right angle triangle, and then this angle is equal to that one there. So this property, we call it the property of alternate segment. So if we see from here, we have 40. Look at this. We have 40. 40 is starting from the tangent, touching the circumference. Okay, so this angle, if we see it, it is equal to this angle. Look at the property. I want you to review the property clearly. This one, this shape here. If you review this shape is the right angle triangle in the alternate segment. Okay, in an alternate segment. So this angle is equal to this one. Okay, so if you have this one as 40, then this one is also 40, like that. Okay, and then also this property, we have to know it. If this one is 40, then that one is 40. Okay, now having this one to be 40, there is also another property that we use in finding the particular angle. Now take note that BD is a straight line. It's 180. It's a line that is passing through the center there. It is adding up to 180. It's passing through the origin. It's adding up to 180. From there to there is 180. Okay, it's 180 like this. When you have a line like that, okay, from the center there is 180. Now from this 180 which we are having there, okay, from this 180, one portion we can find it, this portion for this part we can find it. Now to find this portion, I want you to see this property. This property which we have, which I'll try to demonstrate, is a property which we call angles on the center and then the angles in the circumference. So we have what's known as angles on the center, then the angles in the circumference. Try to see. We have the property of angles on the center, then the angles in the circumference. So this property appears to be in this form. Okay, so we have that. So we have what's known as angles on the center and then the angles in the circumference. So this one, for example, let me say this one is A, then this one is B. If you want to find the angle in the center here, we say 2 times A, and then you get your B, which is the angle in the center. You multiply this twice, 2 times. Say this is an angle in the circumference. So you multiply this one twice, okay, by 2, you get your angle in the center. And then to find this one, it's opposite. We say half times the B, and then we get A. That's how you find this angle in the circumference, okay? So the property just states, in conclusion, it states angles in the circumference, okay, are half the angle in the center. Then the angle in the center is 2 times the angle in the circumference, okay? So this is what we have. So if we want to find this angle here, from the property, if we see this property, this shape, if we see this shape here, it is coming along to the property. Look at the property and then this shape. So this is the property which we're having here. So if this property is shown, then this angle to be found, this one, we multiply this angle here, which is the 40. We're having this as 40. The 40 came out of the alternation in an alternate segment. If this one is a 40, then this one is 40. That's why I'm getting the 40 from. So 40 there, 40, when we have 40 there, you can say 40 times 2. We use this particular principle here. When we say 40 times 2, what you get, let's try to do that. Okay, let's try to do this. Okay, we state 40. We say 40 times 2, we are getting 80 degrees. Okay, that's what we are getting. So this particular point is 80. So if this is 80, what is the completion of the full angle? Because this particular remaining portion which we are looking for, which is AOB like that, it is this remaining portion from 180. The total we should have 180. So to find AOB, we just say 180, which is the sum of the full angle in the straight line, minus 80. Okay, and then what to get there in the end is 100. Okay, so what to get is 100 degrees. Okay, so here AOB, if we see AOB is 100. Okay, so AOB is 100. As we say, 180 minus 80, we are getting 100. So these are the answers which we're having. Okay, so please, for now, we come to an end for this question, and please don't forget to subscribe. You subscribe to my channel, okay? So you subscribe for more videos, because your subscription may motivate me to make more videos. Please help the channel by growing, by sharing the link onto your friends. Invite your friends from WhatsApp, TikTok, and so forth. Okay, and if you need materials, anything, please inbox in the comment section, okay, for more. Thank you. Have a blessed